And good evening. Hope you guys are doing well. Welcome to Bio 1014 Week 10 Digestive System. This is Ian Coates, your instructor, facilitator, however you want to say it. I hope you guys are staying out of the heat, and I just want to say, most importantly, be careful there. Right now, I'm recording this at around 10 o'clock there, Wednesday, July 20th. In the Barrie area, actually in all southern Ontario, we're looking at some really bad storms there tonight, so please be vigilant. I think the storm front is going to be around 8 o'clock tonight, so just be on the alert there between 5 and 8. Safety, I don't care about digestive system if there's no safety, so take it easy. I hope you guys are doing all right. I'm going to try and spin this off there in about an hour and 20 minutes or so. And your test is open. It'll be open there till tonight. Let me know if you guys have any issues. But other than that, digestive system, it's a nice, easy peasy one, and it's only one off here. One lecture, 1 week. All right, very good. We're going to be talking about there the basic anatomy, physiology, the digestive system. We're going to list functions of the digestive system, processes, digestion and absorption. I've been kind of alluding to a lot of these things here. It's just the way to teach anatomy and physiology, right? You can't separate everything completely. So some of these things there, you will have heard me yabber on about there before. We're going to describe their structure and function of the organs and accessory organs like the liver, gallbladder, that kind of stuff. Let's move on, shall we? Here are some, as with any new organ system, there are definitions, right? So digestion itself refers to the mechanical and chemical breakdown of food and absorption of nutrients. Okay? Mechanical, chewing. Chemical, the acid in your stomach, right? Even chemical there, we even have amylase, which is an enzyme in your mouth that begins the process of digestion. If you chew a piece of bread, and I think, I don't know, maybe I've told you guys this before, maybe I haven't. If you take a piece of bread and chew it, take a couple bites of it and start chewing it, but do not swallow. It'll turn into this disgusting gelatinous mess in your mouth. But after about 2 or 3 minutes, you'll notice there that the bread slosh that's in your mouth right now that you keep chewing unnecessarily starts to turn sweet. It's because the amylase enzyme in your mouth begins the process of breaking down starches right there in your mouth. And if you break down starches into its monomers, its basic units, monomers, we're going to get sugar. So glucose, actually. So we're getting there. We'll get there. We'll talk about these all the time here and there in the next hour or so. Mechanical digestion breaks down large pieces of food into smaller ones. Okay, chemical composition is not changed by this process. So you stuff a banana into your mouth, you chew that banana and swallow it, it's still a banana. It's all mushed. Chemical digestion now, here we're talking about, now we're breaking things down and changing their chemical composition. There's absorption. Here we're going to talk about excretion. The digestive unit consists of the alimentary canal, which goes from the rooter to the tutor. And just the whole idea there that if you went hunting and you got yourself a deer, okay, the first thing there that you would do is you would open, and you can actually remove from rooter to tutor the entire digestive system, the alimentary canal. You know that, and you'll see there that in the next slide, right here, okay, you'll see there that it is just one continuous canal, okay, or lumen, L-U-M-E-N. You'll remember there that lumen just means a hole, okay. And yes, the alimentary canal can actually just be removed completely, all right, as it's one continuous tunnel. You got the mouth there, your salivary glands there with the enzyme amylase. You've got we're going to talk about the pharynx, esophagus, the stomach, the pancreas, liver, gallbladder, small intestine, large intestine, rectum, and the anus there. Okay, Everything there should sound familiar. Let's move on. This will be new. I like this one. As with any type of, here we're talking about the digestive system here, like when you swallow, you chew that banana and it hits the back of your mouth and then you swallow it. You don't have control over that banana. You've actually lost control of that banana for probably about 36 hours. And then we see it on the way out. Okay? And the whole idea there that you can swallow a banana upside down. You can go on YouTube and watch people drink a glass of water standing on their head. It's because the esophagus and the entire alimentary canal is smooth muscle. Okay? And when your tummy is rumbling and you're hungry, what's rumbling your tummy? Muscle. Okay? When you swallow that banana and it goes down your esophagus, what's pushing the banana down? The muscle. Okay? And it's doing this there by peristalsis. Okay? Peristaltic action. Okay? Peristalsis is that whole idea of moving of the alimentary canal, squishing itself and propelling, okay, this banana down. It does the same thing there in the small intestine, but we'll get all there. But there are 4 layers that I want you guys to know. There is the mucosa layer. And I'm going to try and zoom in as best as I can, but you guys can zoom in here. With this video here, you guys have the PowerPoint. You know, stop and start it however you like. I've got movies there. Honestly, that's one of the great things there about VR learning is that now it's on your time. And, and you can stop it and start it, and there's no rush and all that kind of stuff. So you got the mucosa layer. You have what's called the submucosa. Okay? You have the muscularis layer. Okay, the muscle layer. This is where the muscle is, the smooth muscle. Okay? You'll notice there that there is a nerve, okay, in this one right here. And then the outside here you have the serosa layer, okay? And you know what I mean, you can read here. You guys can have a look. There's the 4 layers. The innervation of the digestive tract. Innervation just means nerve. You know, the verb to innervate, that's just the whole process of a nerve going zzz and sending its message. So basically what we're talking about here, innervation of the digestive tract, is who's in control of the digestive tract. What's going on here? And then you have what's called the ENS, the enteric nervous system. Regulates the gut motility and secretion, modulated there by the autonomic nervous system, which you guys will all be familiar with. Please know that your assignment, I think, is due next week. I hope everything is all right. Okay. Why do some refer to the gut as the second brain? Because so many of the neurotransmitters that affect the brain also affect the gut. Interesting. Let's start with a bit of anatomy, shall we? And we're going to do a little bit of teeth here. Nothing too crazy, but I want you guys to... there's so much information here in the digestive tract, and this is going to be tested. I think we have one more test there to go before the final. So just be on the lookout for things there that I'm talking about that are, that I make mention that are important here. We've got the scientific word or the medical word for chewing is mastication. Okay? So the teeth are involved in chewing. The tongue is involved in swallowing. Okay? There are 3 types of salivary glands. Okay? And you guys can have a look at these. There's the parotid, the submandibular, and the sublingual. Okay? And you can see them down here. Okay? The 3 salivary glands produce about 1 liter of saliva per day to facilitate swallowing. Okay? They're exocrine glands. So their ducts carry the secretion there to the oral cavity. And, that's where we're at right there. There's other structures there. There's the hard and soft palate. There's your uvula. That's hanging down right in here. We got the palatine tonsils. There's lots going on. Okay? And the nice thing there about this PowerPoint, it comes right from the textbook. So these pictures there, you should see them all in your textbook. The pharynx. This is an area that really isn't an area. There's three. You know, this whole area here, and I'm going to zoom in a little bit, okay? Like when you'll remember there that when we did respiration, the air comes in here and we've got our nasal conchae here, and there's lots of hairs there that, you know, that stop bugs from getting in, bacteria. We've got mucus there that traps bacteria and stuff and dust and all that kind of stuff. But when the air comes in here, it gets all moistened and wet and warm as it goes down, passes the nasopharynx, okay, down through the oral pharynx, and you'll see there that the air comes down here to the trachea. All right, the trachea there has those hyaline cartilage. Okay, when we're talking food, though, all right, food comes into the mouth, chew, 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 chew. Sorry, masticate. All right, and the banana goes back here, and there are sensors back here in the oral pharynx. Okay, that detect food coming through. So what happens there, the soft palate, like there's your hard palate, if you put your tongue to the top of your mouth, okay, that's what we call the hard palate. If you can't really put your tongue back here, I do not recommend it. It might be a choking hazard, but just believe me that there's actually, that hard palate turns into what we call a soft palate. And when you eat that banana, it comes back here. Sensors go off that, okay, we got food coming down. The soft palate goes up, which blocks food from getting up into the nasal cavity here. But sometimes food does still come up here. Like you can go on YouTube and you can see people snort a piece of spaghetti, and they'll have a piece of spaghetti coming out their mouth and all the way around here out their nose. Okay, I didn't invent it. Don't shoot the messenger. But you know, that's what it is. So food can still get up there, but the soft palate prevents food from going up into the nasal cavity. All right, the food comes down here. This goes up, and you'll see there that we do not want food going into our trachea. Okay, choking, the international sign of choking. You put your hands around your neck. You guys all have your first aid. You guys are all on that. But you'll see the food comes down here and it hits the epiglottis and pushes it down. So the epiglottis covers the opening there to the trachea. So all of my yummy banana goes down my esophagus and down to my tummy. So that's how chewing works, right? We've got the nasopharynx, you've got the oropharynx, and you've got the laryngopharynx. The pharynx is all this area back here, but they've broken it up into three different parts because they kind of do three different things. Okay. When we get into the stomach, okay, like I just want to go back here and you see the esophagus. The esophagus there, once you swallow that banana, you've lost control over it now for 36 hours. It's gone. The autonomic nervous system, the smooth muscle, the alimentary canal is doing its thing. And this banana gets squeezed through peristalsis. Squeeze, 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 all the way down until it plops right into the stomach. Okay. The functions there, the stomach regulates the rate of gastric emptying. Gastric juices. Okay. That's just a word for stomach. And you'll even see that the calf muscle, okay, in the lower leg, is called the gastrocnemius. And I don't know who came up with that name, but apparently our calf muscle looks like a stomach. I don't get it either, but that's just fact. The stomach there secretes a gastric juice, okay, including hydrochloric acid. Okay, stomach has a pH of about 2, which is on par with Coca-Cola. It's not the nicest of stuff and breaks down things pretty easily. Okay, so much in fact that your stomach produces mucus, okay, from the goblet cells there, which we'll get into, in order to protect the stomach from the hydrochloric acid. Okay, and the whole idea of an ulcer is that if the stomach is not producing mucus in a particular place, then the acid can actually go and touch the stomach wall, and it'll burn a hole right through it. Welcome to an ulcer, which, as it turns out, is due to bacteria. Okay. What else we got here? Stomach there secretes gastric hormones and intrinsic factor. Digests a limited amount of food, so there is some type of there is digestion, and there is limited absorption. Okay. So, regions of the stomach. Okay, there's your esophagus. Okay, there's your lower esophageal sphincter. I've also seen it called the cardiac sphincter. Okay, and this is the one there if you have a lot of spicy food and you get acid reflux. A sphincter is just a ring of muscle. There's a ring of muscle here and another ring of muscle here. Okay, but if you get some acid reflux, you're going to get some of the stomach contents coming up into the esophagus, which is not really prepared to deal with an acidic environment. So that's why you get this sensation of burning, okay, when you eat some spicy food and you get some acid reflux, okay. The stomach is broken up into a couple of parts here. You'll see that the main area here is called a body, all right. This section there that jettisons up, okay, we call this there the fundus. You'll actually see that there in the not the ovaries, but the, why is it not coming to me? The uterus. Oh my gosh, where's my coffee? Thank you. All right, so you'll see that the uterus actually has a fundus as well. This area there that jettisons up. All right, so this is the fundus of the stomach, the body of the stomach, and down here, this region here, we call it the pylorus. Okay. And this sphincter here, okay, is the pyloric sphincter, and it controls the amount of stuff that's coming out, and that stuff has a name, which I'm going to get into. Okay, so this is the first part of the small intestine, which is the duodenum, or duodenum, however you like to say it. So, esophagus, lower esophageal sphincter, or cardiac sphincter, fundus, body, pylorus, pyloric sphincter, duodenum, duodenum. You'll see these little grooves happening here. And we've talked about this a lot there, that the body is a master of creating space where there is none. And what the inside the stomach here, it's got these 3-dimensional folds and ridges, and we call these rugae. If the stomach was just a shiny, on the inside, shiny, smooth, you know, just a piece of plexiglass on the inside, what kind of traction would we be able to get our food moving around in there? There's got to be some traction. And that's the point of these rugae. They can, through their folds, they can move food around, which is the whole idea. We want to get that food properly mixed up with the hydrochloric acid to break it down, break it down, break it down. Okay, so there's your rugae. Good. The muscles of the stomach, okay, man. As long as you can know, you know there that we're talking smooth muscle, I'm okay with this. Okay, there's the longitudinal muscle, circular muscle, oblique muscle. I'm not too interested in any of these. There's your peristalsis, smooth muscle. That's what's going on. When your tummy's hangry, that's hungry, angry, which my 5-year-old son introduced to me there yesterday. I like that word. I get hangry very much. When your stomach is hangry, it'll start to rumble, and as my son would say, "Dad, I'm hungry. My tummy is wiggling." Once the food plops down, you know, from the esophagus and goes into the stomach and starts mixing with the hydrochloric acid, it now turns into this slurry, and that slurry has a name, and it's called chyme, C-H-Y-M-E. So the chyme is this food acid mixture slurry that's going on around in here, and then what will happen is the pyloric sphincter will open up and a little bit will come out, and then it'll close again. Now, as with the esophagus, the small intestine is not prepared to deal with a highly acidic environment. You know, you could burn a hole right through there as you can through your esophagus. So you'll see there that the pancreas plays a part, okay, and actually injects it's bicarbonate ion, but let's just call it baking soda. And baking soda, you mix it with vinegar, you get a reaction, right? Acid-base reaction. Well, you've got this highly acidic chyme coming in, and the pancreas is shooting in baking soda, okay? Which then neutralizes the chyme, makes it a pH of 7, which should all make sense to you, and if it doesn't, let me know. And now the chyme can go down here to be absorbed. All right. The glands of the stomach here, there are a couple particular cells that I want you guys to know, okay? Mucus cells, okay? What do you think they're doing? Good, making mucus. We've got parietal cells or parietal cells, all right? And these guys here, these are making the hydrochloric acid, okay? But the hydrochloric acid alone doesn't do the job. The chief cells there, they're making these digestive enzymes, okay, that only become activated in the presence of hydrochloric acid, okay? It digests something called pepsin, and then in the presence of hydrochloric acid, it changes into pepsinogen. Okay, so mucus cells make mucus, parietal cells, hydrochloric acid, and intrinsic factor. I'm more interested in this one. Chief cells there are making the pepsin, okay, digestive enzymes. Vomiting, just to let you know, it's not really a stomach event. Vomiting is controlled by the brain, okay? Sneezing, yawning, all these ones there that we kind of do from time to time that aren't really a part of our regular regiment, controlled by the brain. The small intestine, parts and function here, we've got the duodenum, jejunum, and ileum. All right? This is where the majority of the absorption of our food happens. Okay, is in the this is the small intestine. Is the large intestine is not involved in food nutrient absorption. Okay, you'll see that the large intestine is more about water, and that's where our flora all of us have healthy bacteria that live in our intestines, and without it we wouldn't make it. Those are but we'll get there. All right, so I don't want to get too ahead of myself, but the small intestine is involved in food absorption, okay? Functions, digest, absorbs, secretes hormones, digestive enzymes, these kinds of things, okay? Going back into making something from nothing, the small intestine there, the portion of the small intestine there that absorbs the food is only about 1.5 meters, 2 meters long. And you think, and you know what I mean, it's the size of, it's maybe 1.5 inches in diameter. So you're thinking all the food that I need, the protein, everything there that I need, how is it possible that everything that I need can be absorbed in 1.5 meters of small intestine? It seems like absolutely implausible. Well, going back into the body can make something there from nothing. What we've got here is villi. And you'll see there that, I'll zoom in a bit here. You'll see here that this is like the wall of the small intestine, okay? And again, you remember the mucosa, submucosa, they're all here as well, okay? They're the alimentary canal, what is that, slide 15. So this slide here follows true from rooter to tutor, okay? These four right here, okay, there's a mucosa layer, submucosa, muscle layer, and serosa layer, okay? Now, getting back into this, how does the small intestine absorb everything there that we need? Well, you've got villi, okay? You'll see there that we've got these villi, and then we've got microvilli on top of these. So you've got an increase in surface area with an increase in surface area, and then if you blow it right in, you'll see, you can't see them on here, but you'll see these microvilli, which are just these invaginations again on each one of these. So you've got surface area increase on top of surface area increase on top of surface area increase. Okay, villi and microvilli. And there's a shot of your microvilli. Okay, and I don't know if we can see them on here. Yeah, there they are. And they are absorbing everything that you need. If you could take the small intestine, the area there that absorbs, and flatten it out as per surface area, it would be somewhere in the similar as that of the lungs. If you take the surface area of the lungs there, it's about the size of a tennis court, which is the same as the small intestine. And there's enough surface area on a tennis court to digest everything there from your McDonald's meal. All right. So these villi, the folds increase the area for absorption. Okay, inside composed of capillaries and lacteals. Okay, all right, you'll remember there your lacteals there from the lymph system. And you'll see there that in every one of these, you'll see there that there's your cardiovascular system with your lymph right in there. Okay, the end product of digestion delivered to the hepatic portal system. So whatever gets absorbed by the small intestine goes right to the liver. Okay, that's why people who are consuming alcohol on an empty stomach, the whole idea there is that the alcohol, well, it's any type of apple juice, Coca-Cola, alcoholic drink. You know, there's no fiber in these. It's just basically 100% sugar. And alcohol is just another word for sugar. Okay? And no, it's not. But the alcohol can be changed into sugar. The alcohol, sugar from your orange juice or your Coca-Cola, all the sugar gets absorbed immediately and sent right to the liver. Liver kind of freaks out, fibrillates, and then insulin is produced, and you know, if this happens enough times, the insulin will be produced, but then the insulin will not have any effect. And just to remember there that when you have something sugary, okay, and you eat it, it gets absorbed by the small intestine, goes right to the liver. The liver there will start to produce the insulin will be released, okay, and the whole point of insulin is released into the bloodstream. It tells all of your body cells, hey, we got sugar, we got too much sugar in the blood. Okay, the blood sugar is spiked because my owner here, Ian, had a Coca-Cola with sugar, so now my blood sugar is spiked. We need to get all this blood sugar out of here. So insulin is released, which tells the body cells to open up and takes in the excess sugar and removes it there from the blood. Type 1 diabetes, this is a genetic condition where people they do not possess the ability to make insulin or make enough insulin. Okay, so they have to be careful about the amount of sugar there that they intake because they have an insulin producing problem. Type 2 diabetes is not genetic, it's self-induced. Over 20 years, having lots of sugary drinks and all these kinds of things, your body's still producing lots of the insulin, but the cells in the body do not respond anymore to that insulin. So your body's still producing insulin like it didn't care, but the cells aren't receiving the message. So the blood sugar level stays high. Okay, so that's type 1, type 2 diabetes. We'll talk about that more. Sorry for the rambling. The peristalsis in the small intestine absorption, waves of muscle contraction, relaxing. Okay, pushes food from the mouth towards the anus. Peristaltic movement differs from organ to organ. Absolutely. Okay, you guys can have a read in here. Good. The large intestine, okay, you'll see here that there is and it connects there to the small intestine, okay, and then the food, once the food has been, everything has been absorbed, basically, that can be absorbed from the food, it now moves into the large intestine, okay. There's your appendix there. We've got the cecum right in here. We have the ascending colon going up. We have the transverse colon going across. We have the descending colon, okay, going down. Okay, little sigmoid colon. And then we have the anal canal right here. All right. Just to let you guys know that this is where your bacterial flora reside. Main functions here of the large intestine is water removal or water addition as needed. Generally, it's more for water removal, okay, to make the feces more compact. All right, and this is where our bacteria live. And these are healthy bacteria. We wouldn't make it without them. They're the ones there that provide us there with vitamin K. We can't produce that. They do, okay? And they produce gas. They break down things there that we cannot, okay? So we need that. And you'll see the commercials there that, eat our $8 a tub probiotic yogurt. It's so healthy. Replenish your natural flora. Don't go for the expensive stuff. It's all a bunch of crock phooey. All right, cheap yogurt is just the same as expensive yogurt, and it's got the good bugs in there that you need. So eat the good yogurt, eat the cheap yogurt. It's good for you. Go for it. Okay. Functions there: the large intestine, absorption of water and electrolytes, synthesis of vitamins there by the intestinal bacteria, temporary storage of water, and elimination of waste feces and gas flatus. Okay. The muscle movement moves the fecal material there from the cecum through the colon. There's constipation and diarrhea. Okay, they are opposites of the same coin. Constipation means there that a person cannot go to the bathroom. Number 2, diarrhea. You have a sickness here where your body is trying to get rid of something, so floods the feces there with water, okay, to get whatever is bothering the body out. There's 100 different reasons why somebody could get diarrhea. Generally, food poisoning, if you've ever been on holiday or something like that, you get diarrhea, okay, these kinds of things. But with diarrhea, you got to drink the water. You got to drink lots and lots of water, okay? Accessory organs here, we're moving into, what you can see here. We've got the liver, we've got the stomach, okay? Right in here, there, we've got the pancreas, okay? Which is both an endocrine and an exocrine gland, okay? And we'll get into, we're starting to get to the point where we're going to get into hormones a bit, okay? And there is a difference. Endocrine and exocrine, both secreting hormones, but how they do that is different. One of them has a duct. Exocrine has a duct, a throughway, a vessel in which the organ sends out what it needs to send out. You see, like right here, a right hepatic duct. That is a duct. All right. Something is coming down here. There's a hole here, and that something needs to get here for some purpose. Okay. You'll see there with the pancreas as well. There's a duct there as well. Okay. That's an exocrine gland. But an endocrine gland will secrete hormones not through a duct, but just interstitially through the cells, where it'll reverberate and reverberate and reverberate and reverberate until eventually it hits the cardiovascular system, hits an artery or something like that, and then can move through the whole body and get to where it needs to go. We'll talk more about that. But remember, I'm foreshadowing exocrine and endocrine glands. Okay, so we got the liver, stomach, pancreas. There's your duodenum there. We'll get there. Liver function: synthesis of bile salts and secretion of bile, synthesis of plasma proteins, storage of glucose, fat-soluble vitamins, detoxification. Okay, and I think I told you guys there about the loving mother who gave her child, didn't know, wasn't aware, gave the child there those little gummy vitamins, little bear vitamins, and she gave them there to her child there as a candy after school, and the kid was eating 20 or 30 of these after school. Well, and then he started to suffer liver failure. Okay, and I guess this 9-year-old kid had the liver of a 90-year-old drinker, because there's two kinds of vitamins. There's water-soluble vitamins, which we pee them out. We use what we can, but the majority of your water-soluble vitamins we just pee out down the toilet. Waste of money. Then there are the fat-soluble vitamins that do not go out the toilet. They get stored in the liver. And going back to that little kid there who had the liver of a 90-year-old drinker, that's what went on here. All these fat-soluble vitamins went to the liver, and you can never get them out until you utilize them. You know what I mean? So those fat-soluble vitamins are sitting there in the liver, clogging it all up, and yeah, just a nightmare, just a nightmare. So there's your detoxification, okay? Main organ there for drug detox, alcohol detox, everything there goes to the liver. So someone who is a heavy drinker, their liver will start to cirrhose, and cirrhosis of the liver, hardening of the liver, okay? Where the liver, parts of the liver just turn into rock. Not good. Excretion of bilirubin, which is a byproduct there of RBCs. RBC breakdown, cholesterol, drugs, metabolism, carbohydrates, protein, fats, phagocytosis. Okay, these are Pac-Man, chomp chomp. Okay, Kupffer cells, macrophages, these kinds of things. Okay. The hepatic portal system. This is the whole idea there that once the food enters the small intestine, whatever needs to be absorbed from the food, okay, passes through the small intestine and then goes right to the liver through the hepatic portal system, okay? And everything that comes through the small intestine has got to go through the liver to be cleaned up, okay? End products of digestion flow through this portal vein directly to the liver. So anything there that comes from the stomach goes to the small intestine and then goes right through the portal vein, right to the liver, where the liver cleans it all up. Liver processes the end product of digestion, discharges blood through the hepatic veins, and then into the inferior vena cava, okay, off to the heart, and then off to the rest of the body. Okay? You just read down here there. The liver is particularly important for the digestion of protein, which releases nitrogen and promotes the promotion of ammonia, which is toxic to the brain. Only the liver produces urea through the urea cycle enzymes. This allows nitrogen to be safely removed from the body. Okay? So how does the liver help to regulate blood glucose? When blood glucose is high, the liver converts it into glycogen. So this is a good one right here. Glucose can be converted into glycogen, and this is the storage form of glucose. So when there's too much glucose in the blood, the liver will convert it into glycogen, and then this glycogen goes on the shelf to be stored. And when blood glucose is low, like in times of fasting, the liver can convert this glycogen into glucose. So you think about it there, when you have drink a Coca-Cola, I don't know exactly. I'm going to throw a number out here because I think I've heard this there before. I think one can of Coca-Cola has anywhere between, is it 12 to 14 tablespoons of sugar in it? Like, it's just an unrealistic amount. Like, that's enough sugar there for your entire day, I would think. But no, I don't think that would be enough. But generally, at one shot, that's a lot. So when you drink that Coca-Cola, your liver freaks out, all right, and tries to convert all of this glucose there into glycogen. Okay, it's a tough go there for the liver, okay? This is just a kind of a microscopic shot there of what's going on of the liver, the lobules there. I'm not going to really focus too much on this, but, it's formed from blood and there the liver lobules assist in the digestion of fats. There you have your central vein, all right, and the what we're talking, when we get into the gallbladder here, we're talking about bile, okay? Making bile, which bile assists in the digestion of fat, okay? So the bile, kind of a greenish. If when I was teaching this one, I was teaching the same thing there a couple years ago. One of my students said there that they were throwing up so badly, and they didn't have. I guess they had removed all of their entire stomach contents, and then they were throwing up so badly there that they started to see some green, and that is your bile. Okay, that's bottom of the barrel. If you see green, that's it. Yeah, not a very nice process, but the bile is stored in the gallbladder. Composition: water, cholesterol, bile, pigments, salts. Okay, nothing too crazy there. The biliary tree there, ducts there connect the liver, gallbladder, pancreas, and the duodenum. Okay, there's hepatic ducts, cystic ducts, your common bile duct. All right, now these are all, have a look at these. It's all connected. You'll see there in the textbook there that the liver, gallbladder, pancreas, and duodenum, they all have these ducts here that are involved in food digestion. Okay? The gallbladder, pear-shaped sac on the underside of the liver, concentrates and stores bile. Attached to the common bile duct, okay, by the cystic duct there from the liver. Fat in the duodenum stimulates the release of the hormone CCK. All right? And this hormone here causes the gallbladder to contract and eject bile, okay, directly there into the duodenum. So it's amazing there. If you eat an apple, you're not going to stimulate the production there of CCK because it's not a fatty object. But if you eat a Big Mac, your body will sense, okay, man, we've got about 75 grams of fat coming in here. Let's get the CCK going. Okay, we need that bile into the duodenum quick as a bunny. Okay? The pancreas there, located just below the stomach. And I'll just go back here. Now, right here. So there's your gallbladder. All right? There's your pancreas right there. Secretes both endocrine and exocrine substances. In addition to the digestive enzymes, the pancreas also secretes an alkaline juice rich in bicarbonate. There's your sodium bicarbonate. It's not really sodium bicarbonate. It's just bicarbonate. But if you can remember there that this bicarbonate is from baking soda, okay, which is actually sodium bicarbonate, all right? And if you can remember that sodium bicarbonate is a base, which is another word for alkaline, because you remember that chyme is coming out of the stomach into the duodenum, and it'll burn a hole right through the duodenum, so your pancreas sends out some bicarbonate, which then neutralizes the acidic chyme so that it can be absorbed and everyone's happy. Okay? We're going to move on here and explain the physiology of digestion and absorption and some nutritional concepts. Okay? The carbohydrates, okay, digestion and absorption. These are the easiest there for the body to digest. Okay, monosaccharides, simple sugars are the end product of digestion. Okay, so this is the end product. Okay, but sugars are relatively easy to digest. There's your amylase. Okay, for polysaccharides like starch, you chew that piece of bread, it's already starting to be digested there in the mouth. And it's broken down into polysaccharide. Now look at this. Poly means many. Saccharide means sugar. So like a starch molecule, okay, is many, many, many sugars, polysaccharide. And the amylase enzyme in your mouth breaks these down into disaccharides, sugar molecules that are composed of two. Okay? And then we'll break these down there from disaccharides into monosaccharides, which is now what the villi and microvilli in the small intestine are looking for. Okay. The protein digestion and absorption. Gastric hydrochloric acid unravels the strands of protein. So the protein, I don't know, you eat an egg or a ham sandwich or something like this, right? It's all full of protein, and these proteins are massive molecules with crazy three-dimensional shapes. They're completely 3D. They're big, massive beasts. And you put those into hydrochloric acid, what happens is they start to unravel. And this massive, long three-dimensional chain will now unravel into a two-dimensional strand, single piece of string, which is what you want. Because once it's in that, then we can start clipping it and cleaving it, breaking it down into its individual amino acids, where again, that's what the villi are looking for. Okay? Common proteases. I like these. Good. Protein enzymes. Remember ases? Anything to do with an ase is an enzyme. And there we got protein enzyme. Remember amylase. Okay? Sugar enzyme. Pepsin for the stomach. Trypsin for the pancreas. Chymotrypsin there for the pancreas. And enterokinase, the duodenum. Okay? I like pepsin for sure. Definitely know that one. Okay? Maybe even trypsin. These two here, I would know those ones. I'll be able to answer them on a testing situation. Protein and protein splitting enzymes. And you see, there's your protein. And this is pretty simplified. Okay? Like, if this was a real protein, it would be like you'd have, helices over here. And then you'd have these sheets coming off here. And then three-dimensional this. And it's just a massive molecule. Okay? And with the use of these proteases there, you're just clipping and cleaving and snipping, and there you go. And then once we break these down into their individual amino acids, then we can start building, okay, and making them what we want to do. Stomach there, pepsin, okay, with hydrochloric acid, changes into pepsinogen. Pancreas, there's your trypsinogen, okay. And that's all we're looking for there. Those ones there. Fats and bile, digestion and absorption. Fats are insoluble in water. Oil and water do not mix. Fats and water the same. So therefore, like the whole idea of emulsification, okay, what you're doing is you're basically making the fat soluble. Let me say that again. Fats are insoluble in water, but through the use of bile or soap, you can emulsify these and get these things into water. And you think about that. There's the whole chemistry of soap is it's an incredible one. The whole idea there of mixing animal fat with wood ash. The ash left over from a fire. You get soap. And you're able there to emulsify and break down the fats on your hand, which we all have. I have them right now on my hands, and I go wash my hands. And it just allows the fat there to go into the water so that it is, quote unquote, dissolved in the water. All right? And therefore now we can move it through the small intestine. We can move it wherever we want to. And regards to soap and water in my hands, I can remove the fat on my hands, and the water will take it down the sink and away from my hands. So, yeah, it's a good one there. With the bile. Digestion accomplished there with lipases. There's another one. Lipids means fat. Ases means enzymes. Okay. End product there, fatty acids and glycerol. This is what the villi are looking for. You break down a big fatty Big Mac into its fatty acids and glycerol. Now the lacteal, now the villi and microvilli can get their job done. And it says right here, okay, because fat is insoluble in water, the digestion requires an extra step. Bile breaks a large fat globule into tiny fat globules, which can now be removed or dissolved in water. So everything is here. Have a look at it. You guys have the PowerPoint there. Stop and start it as you need. Nutrition, things to know. 5 categories of nutrients there. We've got carbs, proteins, fats, vitamins, and minerals. Okay? Very important. Too much of any of them, big trouble. I don't know. Too much protein. I think you just pee it all out. But too many carbohydrates, your body can change carbohydrates into fats. So if you have too many carbohydrates, you might have weight issues. Proteins, though, generally, you use what you need, and we don't really store protein. Okay? So that's why weightlifters, are people who are taking massive amounts of protein. Okay? Taking protein supplements and all this. It's kind of a waste of money. Okay? Unless you're building muscle on a massive scale. Okay, you really don't need more than, I don't know, was it 30 or 40, 50, you don't need a lot of protein. Okay, so the majority of it there, you just pee out if you don't use it. Fats, your body can store fats. Vitamins, we already know the damages of vitamins. And the whole idea there, minerals, okay, we can have trouble there with too many minerals here. Sorry, just checking something here. There was an alert. So just be careful, everybody. There's supposed to be some really bad weather there today. So I'm going to say that a couple times. For goodness sakes, please take care. Please be aware, okay? Carbohydrates, we have simple sugars. We've talked about these. We've got monosaccharides, one sugar, glucose. Disaccharides, two sugars connected together. An example there, sucrose. Complex carbohydrates, okay, these are the healthier forms, okay, because these ones here are so easy. Your body, if you drink a drink with just table sugar, disaccharide, sucrose, it's not good for the liver because it spikes your blood sugar level, and your liver has a really tough time dealing with this. Polysaccharides, though, here we're dealing with starches. Here we're talking about brown bread, or at least even white bread, but it's slower to digest than the simple sugars. So your blood sugar doesn't tend to spike as much. If you just had apple juice, you're in this, okay? And that would be really bad for your liver. Apple juice is bad for your liver. I'm telling you. Juice is not as freshly squeezed juice. I can see there are living characteristics in freshly squeezed juice. Okay, I get it. That's good. But juice that you buy off the counter there at Circle K that's been sitting there for 3 months, and you pop the top and it goes, right? It's crap. It's really, you'll see there that vitamin C is added, ascorbic acid is added, because this stuff is so healthy, they got to actually add vitamin C to it to try and produce some type of health benefit. So just be careful of your juice, because it will spike your blood sugar, which is, you do that enough times, you're looking at type 2 diabetes. Polysaccharides, though, there's a lot more meat on that bone, so to speak, and your blood sugar really doesn't spike. Like if you eat an apple, there's lots of starch in there, there's lots of cellulose, okay, which is a complex carbohydrate that we cannot really digest. Rabbits can, cows can, but we can't. So the consists primarily of starch or fiber. Okay, there's your cellulose, fiber. We call it roughage, right? It's good for your bowels, cleans you out. Well, it is. We can't digest it. And as the slide and myself agree, most carbohydrate consumption should be in this form. Okay, and you can read in here, talk about glycemic index. You know what I mean? It's all knowledge is power, and I wish nothing but all the power and all the knowledge to you all. Read, learn, acquire, use. Proteins here, essential amino acids. Okay, not synthesized by the body, so we gotta eat. And you know what I mean? You don't have to eat meat to get muscle. Eat beans, man. I think pound for pound, beans have more protein in them than meat. And yeah, we just had, I think we just made some dal from southern Asia, I like to do some cooking there, and the dal on some rice, absolutely outrageous and jam-packed full of protein. Live on this stuff. Love it. Non-essential amino acids here, synthesized in the body, not essential there to consume. You know what I mean? I'm not going to go into any crazy detail here, but just know that there are essential amino acids that we do need to ingest to get. There are non-essential amino acids there that we can make. Complete protein contains all the essential amino acids. Incomplete doesn't. Okay, have a read of that. The fats there are saturated and unsaturated. Saturated fatty acids, solid at room temperature, animal fat, not healthy. And you think about that. If a fat is solid at room temperature, you eat it, what's it going to look like inside your blood? You're going to have little solid globules floating around your blood. This is the stuff there that causes heart attacks, hypertension, high blood pressure. Okay? It can block arteries, atherosclerosis, you know, these kinds of things. Okay, so animal fat should be limited. Unsaturated fat, okay? These are liquids at room temperature. They are vegetable related, okay? Not margarine. Margarine has been tampered with. Margarine is not, it's plant fat that has been modified to be a solid at room temperature. And you know, the horrible thing, if you go to, you know, I can't believe it's not butter, all these things, they say it's healthy, it's unsaturated, it's healthy for you, but no, when they put it into the bucket there in the factory, it's unsaturated, but by the time it gets to you, it's theirs or no frills, it's changed into saturated. So yeah, margarine, not good. But olive oil, sunflower oil, all these kinds of oils, they do not contribute there to heart disease because these are already liquids, and if you put a liquid into your blood, it just doesn't bother. It just flows along like the blood itself. It's these guys here, man, the saturated, man, they will not flow. They are bound by the laws of gravity more so than liquid. So anything solid will go down. Okay? And if we're talking in your artery, okay, if one of these solid pieces goes down and attaches itself there to the bottom of your artery, another one will float along, it will be attracted to it, and it'll stick, and it'll stick. Another one will come, and eventually now your artery gets plugged up. All right, so just be careful. You are what you eat. Fats continued. There's your big fat molecule. Okay, if we add some bile to it, okay, in the process there of emulsification, what you're doing is you're breaking it down into little bits and bobs so that it's, and see, if you look at the surface area here, and what we've done is we've broken this bit into these guys here, you probably quadrupled the surface area. So now your body can attack these guys more so than this. Okay, it's called emulsification. Okay, and then we break it down even more into our lipase, with our lipases here, and then we've got fatty acids and glycerol, and this is what the villi and microvilli are looking for. These guys right here, because now we can take these and start building something else, which is what we do. Vitamins there, small organic molecules that help regulate cell metabolism. There are fat soluble. These ones here never come out unless they're used, so please be careful. Okay? Vitamin D, vitamin A, vitamin E, vitamin K. We do not want those accumulating in the body. Water-soluble vitamins, vitamin B and C, just two examples. We pee those out. Okay? So if you're taking vitamin B and vitamin C supplements, your body will utilize what it needs to and then pee the rest out. Minerals, inorganic substances needed for normal body function. We've got sodium and chloride. This is table salt. Okay, we have potassium. Okay, which comes from bananas. Calcium, well, milk, cheese, yogurt, these kinds of things. Phosphorus and magnesium are there. Iron, iodine. You can get iron there from liver, okay? Iodine, where do we get iodine from? We have to add it there to table salt. Okay, so whenever you see table salt that has been iodized, okay, it's got iodine in there. There's other trace elements in too. You guys can have a look at those there. All right. Balanced diet. You know, you are what you eat. I don't need to go into any of this stuff here. You know what I mean? You guys are a brilliant class, and you guys are all aware of coronary heart disease, stroke, diabetes, cancer. We've talked about these things. Okay. The appetite control. There is more going on in this field currently than you would even know possible. Just the Doritos. My favorite are the orange, the cheese ones. They're just absolutely, aren't they just the best thing ever? And the whole idea of what Doritos. I bet you can't just eat one, right? They're starting to fool around with food chemistry there, and just the whole idea there that the feeding center is in the hypothalamus in the brain. So that is where your hunger comes from. Okay, and here we're talking about theories there, how it all goes here, but we really don't know what makes us eat or stop eating. We can play with these things, and I think that the big major food companies probably know more than they're talking about. Just the whole idea there that if you have one Dorito, you need to eat at least another one, right? And they're playing around with brain chemistry. What's going on here? Why can I not stop at one Dorito? Interesting. In experimental rats there, destruction of the hypothalamus feeding center causes anorexia and starvation. Interesting. In similar experiments, destruction of the satiety center in the hypothalamus causes overeating and morbid obesity. So there's something going on in the hypothalamus there that causes us to eat properly, undereat, or overeat. Okay? I'm sure there's sociological reasons there as well. There are numerous theories about what causes satiety and therefore suppresses the appetite. There's the glucostat hypothesis there that the glucose sends inhibitory information to the feeding center. The lipostat hypothesis there states that the adipocytes, fat cells, they secrete a hormone leptin, which is an appetite suppressant. Have a read of that. You know what I mean? Interesting theories. And again, knowledge is power. And make sure that you read these things there just before bed. You'll have the best sleep you've ever had in your whole life. And the end of the slide here, just the whole idea. Have a look at everything here. Everything is good to go. I don't think, the spleen, that's just on there just to show you, but have a look at everything here. Everything here we mostly covered. And so this is week 10, week 11 there. I think we are moving on. I can't remember what we're hitting there for week 11, but I hope you guys have a great week. If there's any issues there with the assignment, let me know. But other than that, please take care there today. I don't want you guys getting into any type of weather-related issues. And good luck on your test there today. Take it easy, guys, and we'll talk to you later. We'll see you there next week. Bye for now.